Thank you. Good morning, learners. Good morning, teachers. Let me take this opportunity again to welcome you all in this session. And in this session, the session that will be focusing mainly on trigonometry. Remember, paper 1 was written yesterday, and I believe that you did well. So we need to prepare thoroughly. We need to prepare thoroughly for this coming for paper 2 on this coming Tuesday. It will still be written out of 150 marks, and it will still be a 3-hour paper. So please, you need to do a thorough revision. We need to do a thorough revision to make sure that we do well in that paper. Without any waste of time, then, let me start with today's session. But before I start with today's session, maybe it is important for me to indicate to you that I'm going to be with you until 10 o'clock, and I'll be focusing mainly on trigonometry. The part that I'll be focusing on will then be the reduction formulae, general solutions, and the Pythagorean type of problems, whereby we have to use Pythagoras theorem to solve such problems. As for at 10:30, then my colleague will also join me here, will also come, and my colleague will then be focusing on the trigonometric functions, and he will also be focusing on 2D and 3D problems. So without any waste of time, let me start with the session. As I have indicated earlier, my name is Mohapi, and I'm working as a subject advisor for mathematics in Mutao district. Let's start with the trigonometry revision. Remember, like I said earlier, I said the trigonometry is part of paper 2. You see, trigonometry is part of paper 2. Here it is, that trigonometry, and it weighs 60 marks. The paper will be written out of 150 marks, but we say trigonometry alone was going to contribute 60 marks. So today's session is very, very much important. Really, today's session is very much important because we're talking of a topic that weighs 60 out of 150 marks. So we need to concentrate and do our best. I'm going to give you lots and lots of exercises to do. Remember, in mathematics, we say practice makes perfect. You need to practice. This is the time for you now to start practicing. So in this revision session, I'll be focusing on trigonometry. And then I've got the formula sheet will also be given in this coming examination. On Tuesday, I believe paper 2 will also be provided with the formula sheet. And what is important with regard to trigonometry in this formula sheet is the following. See, in any triangle ABC, the sine rule, the cos rule, and the area rule. And we also have got the compound angles for cos and sine, alpha plus beta. We also have a compound angle for sine and cos alpha minus beta. We also have, in the formula sheet, we will also be given the formulae for a double angles. Lucy, cos 2 alpha is equals to 3 options, cos squared alpha minus sine squared alpha, or alternatively, 1 minus 2 sine squared alpha, or lastly, 2 cos squared alpha minus 1. So cos 2 alpha has got 3 options. It's up to you which formula would you prefer. As for the sine of 2 alpha, the sine of 2 alpha here, you can see sine of 2 alpha equals 2 sine alpha cos alpha. This is a very important formula. This is a very important formula. Compound angle for cos and compound angle for sine. Here we've got, what is it, a compound angle for alpha minus beta, compound angle for alpha minus beta for sine and cos respectively. Here is alpha plus beta for sine and cos respectively. This one is a double angle for cos. Double angle for cos, like I indicated, we've got 3 options, cos squared alpha minus sine squared, or 1 minus 2 sine squared, or 2 cos squared alpha minus 1. And the sine of 2 alpha, a double angle for the sine of 2 alpha, 2 sine alpha cos alpha. Thank you. Let me start with the reduction formula. Just a brief revision of the reduction formula. I know even in the previous session when I was here, I also handled the very same topic, and I did take you through this revision session. So the reduction formula, 180 degrees minus. As I indicated earlier on, if you can still remember, I said what is important about the reduction formula is for you to be able to identify the quadrant. What is important is for you to be able to identify the quadrant. Let's check this one for a minute. I said we've got the Cartesian plane, the x-axis, and the y-axis. And a Cartesian plane has got 4 quadrants. It's first, second, third, and fourth quadrant. These are the 4 major quadrants. These are the 4 major quadrants. And if in this exercise, let me say we're going to have an angle here, let's denote it by theta. And in this case, this theta will then represent an acute angle. An acute angle. Remember, an acute angle is an angle greater than 0 degrees but less than 90 degrees. So, thank you. Okay, let's say we've got a Cartesian plane here. We've got a Cartesian plane, the horizontal x-axis and the vertical y-axis. It's a Cartesian plane, and here the point of intersection of the 2 axes is called the origin. It is called the origin, and the coordinates of the origin is 0 and 0. Thank you. We've got a Cartesian plane. A Cartesian plane is divided into 4 quadrants. Quadrant number 1, quadrant number 2, third quadrant, and fourth quadrant. So basically, the main intention of me bringing in this session is to show you the how do we name angles in various quadrants. So I'll make an example of an angle we call theta, and in this case, theta represents an acute angle. An acute angle. Remember, an acute angle is an angle less than 90 degrees but greater than 0 degrees. Between 0 and 90. That the magnitude of that angle is between 0 and 90. Therefore, that angle is called an acute angle. So, angles in the first quadrant. Remember, we've got 0 degrees here. We've got 90 degrees there. On this line here, we've got 180 degrees. On this line, we've got 270 degrees. And again, we've got 360 degrees there. So, from here up until it's 90 degrees. So, from 90, if you subtract an acute, then you've got 90 degrees minus theta. Then that will be angle in the first quadrant. This is 90. If you say 90 plus theta, then it will be an angle in the second quadrant. Alternatively, the very same angle in the second quadrant. Remember, here we've got 180 degrees. From here, it's 0, 180 degrees. It's an angle on a straight line. That angle is 180 degrees. So from 180 degrees, if you subtract that acute angle, then you'll be in the second quadrant. So again, angles in the second quadrant can also be expressed as 180 degrees minus theta. Thank you. Here we are at 180 degrees. If you say plus, 180 degrees plus, it means you will then be moving in the third quadrant. Hence we say 180 degrees plus theta represent an angle in the third quadrant. Check the fourth quadrant. This angle here is a revolution. You start from 0 up until here. It's a revolution. It's 360 degrees. From 360, if you subtract theta, remember theta is an acute angle. From 360, you subtract theta. Then you've got 360 degrees minus theta. Therefore, that will be an angle in the fourth quadrant. So basically, in reduction formulae, what is important is for you to be able to know in which quadrant does this compound angle lie. If you see 180 degrees plus, then you must know that is an angle in the third quadrant. 360 minus, then you must also know that it's an angle in the fourth quadrant. Accompanied with this will then be the cast diagram. It is important again to know, to understand the cast diagram. Check. The Cartesian plane, the horizontal axis, the x-axis, and the vertical ones, the y-axis. We've got the first quadrant, the second, the third, and the fourth quadrant. Like I said earlier, a Cartesian plane is divided into 4 quadrants. Thank you. So according to cast diagram, this is how cast diagram looks like. It's a cast diagram. C stands for cos, A for all, S stands for sine, T for tangent. So basically, the role of this cast diagram is to indicate positive trig ratios. I said cast diagram. Cast. Its role is to indicate positive trig ratios. The role of cast diagram is to indicate positive trig ratios. If we've got C here, it means in the fourth quadrant, cos is positive. If you've got A here, A represents all. So it means in the first quadrant, all trig ratios are positive. In the second quadrant, we've got S, which stands for sine. So it means the sine in the second quadrant will then be positive. And in the third quadrant, tangent will be negative. So we said the role of the cast diagram is to indicate positive trig ratios. Then it goes without saying that those that are not indicated are therefore not negative. Check. In the second quadrant, sine is indicated. Which trig ratios are not indicated? In the second quadrant, sine is indicated there. Which trig ratios are not indicated? It's tangent and cos. So in the second quadrant, there is no tangent, there is no cos. That means tangent and cos are therefore negative in the second quadrant. Just like in the third quadrant, what is indicated there is tangent. Cast diagram, it indicates positive trig ratios. So in the third quadrant, tangent is positive because it is indicated there. T represents tangent. So tangent is positive in the third quadrant. There is no sine here, there is no cos. This means sine and cos are therefore negative in the third quadrant. Even in the fourth quadrant, cos is indicated, is therefore positive. Sine and tangent are not indicated. As a result, sine and tangent are therefore negative in the fourth quadrant. So you need to understand the cast diagram as well as the quadrant in which the angles lie. The quadrant in which the angles lie. You see 180 minus, you know, is the second quadrant. You see 90 minus, you know, it is the first quadrant. You see 360 minus is the first quadrant. Let me indicate another angle again in the first quadrant. Remember I said from here 0 degrees anti-clockwise direction until here is 360 degrees. It's a revolution. So if you say 360 plus an acute 360 degrees, 360 degrees plus theta will then be an angle in the first quadrant again. Thank you. Let me take you through the reduction formulae quickly. A brief revision of reduction formulae. Thank you. The reduction formulae. In reduction formulae, the first reduction formulae, 180 degrees minus. What is important about 180 is that 180 degrees minus, like I indicated earlier, it is an angle in the second quadrant. So according to cast diagram, sine is positive in the second quadrant. That's why 180 minus represents the second quadrant, and in the second quadrant, sine is positive. That's why we've got, if you reduce it, it becomes sine theta. Check 180 degrees minus is still a second quadrant, but in the second quadrant, we say this cos here is negative. That's why when you reduce that compound angle to acute, it becomes minus cos theta. Why minus? Because 180 degrees minus is an angle in the second quadrant, and in the second quadrant, cos is negative. Look at tangent. 180 degrees minus theta is second quadrant, and in the second quadrant, tangent is negative. Therefore, we've got minus tan theta. This is a reduction formula for 180 degrees minus theta. Thank you. Let's check at 180 degrees plus theta. Which quadrant? The most important thing, in which quadrant does 180 degrees plus theta lie? So 180 degrees plus theta lie in the third quadrant. So in the third quadrant, we know according to cast diagram, in the third quadrant, tangent is positive. That's why you've got positive tan theta there. But because 180 plus is in the third quadrant, and in the third quadrant, sine and the cos are negative. If you reduce them, it becomes minus cos theta and minus sine theta. That's the reduction formula for 180 degrees plus theta. And 180 degrees plus theta is an angle in the third quadrant. Check 360 degrees minus theta. 360 minus theta, you remember I did it earlier with you. I did indicate to you that 360 degrees minus theta is an angle in the fourth quadrant. According to cast diagram, do you still remember the trig ratio, which is positive in the third quadrant? It's cos. It is cos. Thank you. Therefore, 360 minus theta is an angle in the fourth quadrant. And in the fourth quadrant, according to cast diagram, sine is negative. That's why you got minus sine theta. 360 minus theta, fourth quadrant. In the fourth quadrant, cos is positive. That's why we end up with positive cos theta. But in the fourth quadrant, tangent is negative. We end up with minus tan theta. So what is key with regard to this reduction formula is for you to know, to understand the cast diagram. Is for you to understand the cast diagram. In other words, the cast diagram will then indicate the sign of various trig ratios in various quadrants. At the same time, you must also know as a learner in which quadrant does the angle lie. If we talk of 360 degrees minus theta, it's a compound angle in the fourth quadrant. 180 degrees plus theta is a compound angle in the third quadrant, and 180 degrees minus theta is a compound angle in the second quadrant. Let's carry on there. 360 degrees plus theta, the last one that I did with you earlier, is an angle in the first quadrant. And in the first quadrant, remember, we've got the letter A, which represents that all trig ratios are positive in the first quadrant. That's why you look at 360 degrees plus theta. All the trig ratios here, they are all positive. Are we still together? Thank you. Let me carry on with the reduction formula. Let's talk about the negative angles. Let's talk about the negative angles and see how do we work with the negative angles. Let's start the negative angles. Let's talk about the negative angles. Remember, let me draw a Cartesian plane. There we are. The vertical axis, the y-axis, and the horizontal one, the x-axis. This is still the origin, the point of intersection of the two axes. The origin, point of intersection of the two axes. In mathematics, when you measure angle, we start from this positive x-axis. So you can either move in that direction when you measure an angle, and you've got a terminal arm here. So this angle, say it is theta. This angle is measured in an anti-clockwise direction. You remember the direction of the clock. So this is against the direction of the clock. Therefore, these angles which are measured in an anti-clockwise are referred to as positive angles. These are positive angles. In other words, positive angles are angles that have been measured in an anti-clockwise direction. If you measure an angle in a clockwise direction, it's in line with the direction of the clock. So we've got a terminal arm here. This angle has been measured in a clockwise direction. Clockwise direction. Therefore, angles measured in a clockwise direction are referred to as negative angles. So this one will then be negative theta, because it's an angle which has been measured in an anti-clockwise, it's an angle that has been measured in a clockwise direction. It's key for you to know that. Angles measured anti-clockwise are referred to as positive angles, and those that are measured in a clockwise direction are therefore negative angles. Remember, in this case, we said theta represents an acute. So if you measure from this axis in a clockwise direction an angle less than 90, it means that angle will be in the fourth quadrant. Remember, we've got the first quadrant here, the second quadrant, the third, and the fourth quadrant. So it means the negative angles here, this is negative theta, negative theta. Negative angles therefore lie in the fourth quadrant. Once you see negative theta, theta represents an acute, therefore negative theta will be an angle in the fourth quadrant. And you still remember, according to cast diagram, in the fourth quadrant, cos is positive, whereas sine and tangent are negative. Thank you. Let's carry on with the PowerPoint presentation there. Thank you. Let's start with the negative angles. Like I indicated earlier, negative angles, those are the angles that lie in the fourth quadrant. So in the fourth quadrant, according to cast diagram, negative angles, fourth quadrant. Negative angles, fourth quadrant. And in the fourth quadrant, cos is positive. That's why we've got positive cos theta. But fourth quadrant, sine is negative. We've got minus sine theta. Fourth quadrant, tangent is negative. We've got minus tan theta. Negative angles are the angles that lie in the fourth quadrant. And in the fourth quadrant, cos is positive. That's why it's only cos that becomes positive. The rest of the other ratios becomes negative. That's it about reduction formulae. I haven't talked about the 90 plus and 90 minus. Remember, 90 degrees, we said 0 degrees here. We've got 0 degrees. Measured clockwise, 90 degrees is on the y-axis. So once you use 90 degrees minus or 90 degrees plus, one thing that you should always remember is the cofunction. Sine changes to cos and cos changes to sine. When you see 90 plus or 90 minus, then you must change sine. Sine will change to cos and cos will change to sine. Those are called the cofunction. Thank you. The first one, 90 degrees minus theta. Remember I said 90 degrees minus theta is an angle in the first quadrant. So in the first quadrant, cos is positive. But because it's cos, it will have to change to sine. We've got 90. Once we have 90, sine will change to cos and cos will change to sine. Don't forget that. And definitely you're going to come across one problem that requires that concept of cofunctions. 90 degrees minus is the angle in the first quadrant, but you see 90, then cos will change to sine. The sine of 90 degrees minus theta. 90 degrees minus theta is an angle in the first quadrant. Sine in the first quadrant is positive, but now it will change to cos because once you see 90, then we talk of the cofunction. By cofunction, I mean sine will change to cos and cos will change to sine. Sine will change to cosine and cosine will change to sine. Hence we talk of the cofunctions. You see the prefix CO for cos start with the cofunction. Thank you. Let's go to 90 degrees plus. 90 degrees plus is the second quadrant, angle in the second quadrant. The original function is cos here. 90 degrees plus is an angle in the second quadrant. And in the second quadrant, cos is positive. That's why we've got, cos is negative according to cast diagram. Cos is negative in the second quadrant. That's why we've got negative sine theta. Remember 90, sine will change to cos and cos will change to sine. The fact that we've got 90 here, cos will change to sine. So you check the sign of the original function. We say 90 degrees plus is an angle in the second quadrant. And in the second quadrant, cos is positive. That's why we've got, cos is negative. That's why we've got minus sine theta. Thank you. The next one, the sine of 90 degrees plus theta. 90 degrees plus, second quadrant. And in the second quadrant, sine is positive. That's why we've got positive cos theta there. You check the sign of the original function. In this instance, cos is the original function. Therefore, we say, what is the sign of cos in the second quadrant? It's negative. That's why we've got negative there. That's why we've got negative there. That's why we've got negative there. 90 degrees plus is minus sine theta. The sign of 90 degrees plus is cos theta. Let's talk about the compound angles. This one I'll be quick because these are the formulae that appears in the formula sheet. The sign of alpha plus b, a plus b, and the sign of a minus b. Remember, sign alpha a plus b is equal to the sign of a cos of b plus the sign of b the cos of a. This is the first formula for compound angle, and the second one is this one. Sign of a minus b is equals to the sign of a the cos of b minus the sign of b the cos of a. These are the compound angle for sine. Cos. The compound angle for cos. The cos of a minus b is cos a cos b plus sin a sin b. The cos of a plus b, the cos of a, the cos of b minus the sin of a, the sin of b. Remember this formula. I don't want to spend much time on this one because they will be given to you in the formula sheet. In case you have forgotten the formula, you look in the formula sheet, the formula will be there. You must also remember Sine squared A plus cos squared A is equals to 1. That is the trig identity. That's the trig identity. Do you know the another trig identity? The other one is the one that states tan theta is equal to sine theta over cos theta. In other words, the tangent of A is equal to the sine of A over the cos of A. That is another trig identity. Let's talk about the double angles then. When do we have a double angle? Remember, a compound angle, we had A plus B. So if A is equal to B, then you can substitute either by the other. You can substitute A by B. Then you'll have the sine of A plus A, and A plus A will end up giving you 2A. That's why you've got the sine of 2A here. It's A plus A. It's 2A. So once you've got 2A, then we call them the double angles. Two double angles. And the double angle for sine is 2 sine A cos A. It will also be given in the formula sheet. Cos 2A is equal to cos squared A minus sine squared A. The double angle for cos. And for cos, remember, we've got 3. This is the first one. If you've got this, remember, we've got from the trig identity, sine squared A plus cos squared A is equals to 1. If we make sine squared A the subject of the formula, then sine squared A will then be equals to 1 minus cos squared A. So you substitute here. Instead of sine squared A, put in brackets, and you substitute sine squared A by 1 minus cos squared A. Then what do you get? You'll get 2 cos squared A minus 1. Therefore, it means another double angle for cos will then be cos of 2A is equal to 2 cos squared A minus 1. Remember, cos squared A is also equal to 1 minus sine squared A. The basic identity, it was sine squared A plus cos squared A is equal to 1. So if you make cos squared A the subject of the formula, you'll have cos squared A, which is equal to 1 minus sine squared A. So what does this tell us? It means whatever you see cos A, you've got cos squared A. Here is cos squared A. We're going to substitute cos squared by 1 minus sine squared. If you, here, cos 2A is equal to cos squared A minus sine squared A, you substitute cos squared A by 1 minus sine squared A. What do you get? You get the cos of 2A, which is equal to 1 minus 2 sine squared A. Those are the double angle formulae. And these formulas will also be given to you in the formula sheet when you write the examination. Thank you. Let me take you through some few exercises in trigonometry. I think I'll have to start with the Pythagorean type of problems. By Pythagorean type of problems, those are the problems that requires the application of Pythagoras theorem. Those are the problems that requires the application of Pythagoras theorem. Let me take you through some few examples. This is the section. Let's call it section A. In this section, we'll be focusing on the Pythagoras type of problems. This is the problems that requires the use of Pythagoras theorem, the application of Pythagoras theorem. Thank you. Do you know the Pythagoras theorem? It states, in a right-angled triangle, the square on the hypotenuse is equals the sum of squares of the other two sides. In short, learners used to express it as r squared is equal to x squared plus y squared, where r represents the hypotenuse, x and y represent adjacent and opposite sides respectively. Thank you. Here is a problem. Sketch diagram. A sketch diagram must be used for the following exercises unless otherwise provided. Thank you. Check. The first one. Here it is. If the sine of 37 degrees is equal to t, the sine of 37 degrees is equal to t, express each of the following in terms of t. What does that tell you? Once you come across a problem like this, you say 37 degrees, that is an angle in the first quadrant. You first draw a Cartesian plane, the x-axis and the y-axis. Then your angle, let's assume it's positive angle. It means it was measured in an anti-clockwise direction. This angle is 37 degrees. And then you complete a right-angled triangle. You complete a right-angled triangle. There we are. And it is given that the sine of 37 degrees is equal to t. Remember, sine of 37 degrees is equal to t. Basically, it's t over 1. Basically, it's t over 1. T divided by 1 gives you t. So here it's simplified. So what does that mean? By definition, we define sine is defined as opposite side over hypotenuse. You look at this diagram. This is 37 degrees. The opposite side will then be t, and the hypotenuse will then be 1. This side is t, this side is 1. So what is the length of the side? That's why with these problems are called the Pythagoras type problems, because we need to determine the length of the remaining side. So for us to determine the length of the remaining side, we have to apply the Pythagoras theorem. And according to Pythagoras theorem, this is the hypotenuse. 1 squared is equals to t squared plus this side, we don't know its length, let's call it x. It's equals to x squared. Now we start solving for x. 1 squared is 1. You've got t squared there, you transpose it to the left, it's minus t squared. Then you are left with x squared. Now we determine the length, we determine the square root on both sides, the positive root on both sides. Therefore, x will be equal to the positive root of 1 minus t squared. Therefore, it means this side here, this side will then be 1 minus t squared, the square root thereof. And its positive root, we have indicated the positive root because we want to determine the length of this side from here up until there. The length is a scalar quantity, it's always positive. So let's answer the question then. From this given statement, if the tangent of 37 degrees is equal to t, express each of the following in terms of t. Let's check the first one. The sine of 37 degrees. Let's check the sine of 37 degrees. So by definition, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Yeah. Basically, this diagram refers to tangent. We were given the tangent of 37 degrees is equal to t. Tangent of 37 degrees is equal to t. Maybe I need to apologize that because I refer to that as tangent. As a sine, it's a tangent of 37 degrees is equal to t. And this will be the approach. I'm sorry for that. The question is the tangent of 37 degrees is equal to t. So you need to draw x, y, complete a right angle triangle. This angle measured in an anti-clockwise is 37 degrees. So tangent of 37 degrees is equal to t. It's t over 1. Tangent, basically, tangent is opposite over adjacent. So the opposite side is t, the adjacent side is 1. So for us to determine the remaining side, we then use the Pythagoras theorem. This side we don't know. Let's call it r. Therefore, we say r squared is equal to 1 squared plus t squared. This side. Tan 37, opposite adjacent. Opposite over adjacent. So r squared will be equal to 1 plus t squared. To determine the length of r, you determine the square root. Therefore, r will be equal to the square root of 1 plus t squared. So here we've got the square root of 1 plus t squared. Now we can use this diagram to answer any question. First question, the sine of 37. Here is 37. Sine is defined as opposite over hypotenuse. Opposite over hypotenuse. Therefore, the sine of 37 degrees will then be equal to, opposite is t, hypotenuse is the square root of 1 plus t squared. That is how we answer the first one, the sine of 37 degrees. Check the next one. The cos of 74. The cos of 74. The cos of 74 degrees. So the question is, in this diagram, this angle is 90, this one is 37. This one, for you to determine the size of this angle, you need to subtract 37 from 90. So this angle will be 53, but we still don't have 74. But if you apply your mathematics correctly, you will remember that 74 is basically twice 37. So we say cos of 74 will be equal to 2 times, this will be the same as, the cos of 2 times 37 degrees. 2 multiplied by 37 will give you 74. 2 multiplied by 37 will give you 74. So if you simplify it further, remember the cos of 2 alpha. The cos of 2a is a compound angle for, is a double angle for cos. And the double angle for cos, we can express it as 1 minus 2 sine squared, or 2 cos squared minus 1, or cos squared minus sine squared. It's up to us. So the cos of 2 alpha, we can express it as 2 cos squared 37 degrees minus 1. And then we simplify it. It's 2. We start checking the cos of 37. 37 is here. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. It's 1 over the square root of 1 plus t squared. Because it's cos squared, you also square this one. Minus 1. Let's simplify. Let's simplify. 2. Here is 2. Cos of 37. Cos, I said, is, look at this, adjacent hypotenuse. 1 over 1 plus the square root of t squared. Because it's cos squared, you square it. Here is minus 1. If you simplify it further, you have 2. Let's square that one. It will be 1 over 1 plus t squared. Minus 1. Minus 1. And then you multiply throughout by 2. You will end up with 2 over 1 plus t squared minus 1. You can look for LCD, or you can just leave it like that. Let's look for LCD. Our LCD in this case will be 1 plus t squared. So this into the denominator into this goes once. 1 multiplied by that gives you 2 minus, this is over 1. 1 into this is 1 plus t squared. 1 plus t squared multiplied by that one is going to be 1 plus t squared. So you simplify it further, you'll have 2 minus 1 minus t squared all over 1 plus t squared. 2 minus 1 will give you 1. So 1 minus t squared all over 1 plus t squared. That will be the value of the cos of 74. For you to be able to solve that one, you need to know the compound angle, the double angle for cos, because here what is given, originally in our diagram, we had 37 degrees. So the question talks about 74. So you must play around with your arithmetic and know that 74 is the same as 2 times 37. So 2 times 37 then give you a double angle for cos. Let's check the next one. The tangent of 3,997. It looks difficult. It looks difficult. But truly speaking, it isn't that much difficult. Because remember, if you have a Cartesian plane, we said start from 0, 90, 180, 270, 360. So it's 3,009. It means 3,997. It's like this 360, you've got to multiply it by 10. 10 revolutions. 10 revolutions will then give you 3,600. So the question is, if you've got 3,600, what must we do to 3,600 to get 3,997? Let's add another revolution. If you add another revolution, remember a revolution is 360 degrees. It's 360 degrees. If you add that, then you'll end up with 0, 60, 90, 3,960 degrees. It's still here, the revolution. You're still at that particular point again. So what must we do to get 3,997? We've got 3,960. 3,960 degrees, which is here. It's a revolution. It's 11th revolution. It's here. So what must we do to get 3,997? It means to 3,960, we need to add another 37 degrees. When you solve this one, remember you've got the tangent of 3,997 degrees, which is equals to the tangent of 3,960 plus 37, because 3,960 plus 37 will still give you that one. And 3,960, the 11th revolution is here. You are still at this point. So if you say 360 plus, then you are moving in the first quadrant. And remember, in the first quadrant, we said all ratios are positive, meaning that tangent is also positive in that. Therefore, we'll also have the tangent of 37 degrees. Then we have the tangent of 37 degrees. Now, if you have the tangent of 37 degrees, you go back to the problem. Remember, the tangent of 37 degrees is equal to t. You have to express this in terms of t, then it can just only be t over 1. Or if you use a diagram, the tangent of 37, opposite over adjacent, t over 1. And t over 1 is the same as t. Interesting. Thank you. I've been doing lots and lots of problems. Maybe I should give you a chance to solve this one for me. Let's try this one. Only 2 of them. Only 2 of them. You are given that the sine of 44 degrees is equal to m. The sine of 44 degrees is equal to m. I think it's clear and you can see it clearly. Given the sine of 44 degrees is equal to m, express each of the following in terms of m. I've got the sine of 224 and the cos of 88. I'll give you 5 minutes to work through that one, and then after 5 minutes, I'll then come and present you the solution to this problem. Thank you. 5 minutes. Thank you. Let's check the solution quickly. Let's check the solution. 2.2. In 2.2, you have the sine of 224 degrees. The question is given the sine of 44 degrees is equal to m. Express each of the following in terms of m. I said the first thing that you need to do, draw a right-angled triangle. These are the x-axis, the y-axis. A right-angled triangle in the first quadrant. This angle is 44 degrees. 44 degrees. Thank you. Measured in an anti-clockwise direction. It's positive. 44 degrees. So what is given here? The sine of 44 is equal to the sine of 44 degrees is equal to m. It's over 1. M over 1, which is m. M divided by 1 gives you that m. So sine here, sine 44, it's opposite over hypotenuse. So the opposite here will then be m. The hypotenuse will then be 1. Opposite is m, hypotenuse is 1. And then we use the Pythagoras theorem to determine the length of this remaining side. So horizontal one, let's call it x. Let's calculate x. According to Pythagoras theorem, 1 squared is equals to m squared plus x squared. This side you said it's x. Now we need to determine the value of x. Your square 1 is 1. It's 1, which is equals to m squared plus x squared. You transpose m, you've got x squared here. If you transpose m to the left, it comes 1 minus m squared. Then to determine the x, you determine the square root. Therefore, x will be equal to the square root of 1 minus m squared, according to Pythagoras theorem. So this side is 1 minus m squared. This angle is 44. And that one you must know, that one is 46. If this one is 44, that one will be 46. Check. 2.2. 2.2, the question states determine the value of the sine of 224 degrees. Let's check the sine of 224. 224 is the angle. This 224, it is an angle in the third quadrant. And in the third quadrant, remember we said 180 plus. So we can have the sine of 180 degrees plus. What must we add on 180 to get 224? We must add 44 degrees. Thank you. Let's simplify it further. 180 plus, remember, third quadrant. 180 degrees plus is third quadrant. And in the third quadrant, sine is negative. Then you've got minus the sine of 44 degrees. Minus the sine of 44 degrees. Then it's minus the sine of 44. Remember 44 opposite m over 1. Sine 44 m over 1. Therefore just negative m. Clear? Thank you. Let's do the second one before we go for a break. The cos of 88 decrease. 2.3. The cos of 88 decrease. Very much similar to the previous example that we did, because 88 is 2 times 44. Let's check. It's going to be the cos of 2 times 44 decrease. Every time we try to work with this angle, 44. If it's not 44, then we must work with 46, because the angle here is 46. This one is 44. All the angles in this triangle, they must give you 180 degrees. So if this one is 44 degrees, that one must be 46. Every time, try to split this angle in such a way that you have 44 or you have 46. So in this case, 88 will be the same as 2 times 44 degrees. Then we have a double angle for cos. And a double angle for cos, remember we said the cos of 2 times 44 is the same as cos squared 44 minus sin squared 44. You can say it's cos squared 44 degrees minus sin squared 44 degrees. Or you can say 2 cos squared 44 minus 1, or you can say 1 minus 2 sin squared 44. Remember, cos, we've got 3 options. So this is the option that we chose now. We work it out, simplify it further. The cos of 44. Cos, look at the diagram. Cos adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent is square root of 1 minus m squared. Because it's squared, you also square it. All over 1. Hypotenuse is 1. All over 1. Minus sine. Sine of 44. Opposite hypotenuse. Opposite hypotenuse. So opposite is m, hypotenuse is 1. But because it's squared, you also square it. Let's simplify it further. If you square 1 minus m squared, the square root of that, if you square it, you'll only be left with 1 minus m squared. Minus m squared. So ultimately the answer will then be 1 minus 2m squared. That is how we can express the cos of 88 degrees in terms of m, if it is given that the sine of 44 degrees is equal to m. If the sine of 44 degrees is equal to m, and we are asked to express the cos of 88 degrees in terms of m, step number 1, break it down into double angle. And you know the double angle for cos, you've got 3 options. Either options will give you the same answer. So in this case, you opted for cos squared 44 minus sin squared 44. And the cos of 44, adjacent hypotenuse. The sine of 44, opposite hypotenuse. That's why we've got this expression here. 1 minus m squared over 1 minus m squared over 1. Then because they are squared, you square here 1 minus m squared. Because once you square a radical, you eliminate a side. Square there is a reciprocal of the root sign. So square root multiplied by the square root basically is exponent half. That exponent half multiplied by 2, they will eliminate each other. Hence we are only left with 1 minus m squared. And here you've got minus m squared. Minus m squared, those are the like terms. We add them together. Minus m squared and minus m squared will give you minus 2m squared. That's why we say this will be how we can express the cos of 88 degrees in terms of m, if it is given that the sine of 44 degrees is equals to m. Thank you. When you come, I'm going to give you a short break. I'm going to give you a very short break. Let's say 10 minutes break. After 10 minutes, when we join here, we'll be dealing with problems from the previous question papers. But those problems will only be relating to the Pythagorean type. Thank you.